Hello everybody and welcome to the first video on this channel. You can see the YouTube channel above in blue along with an email address. If you have any suggestions, questions, I guess, if you want me to kind of go into more detail on something or if something just didn't quite click to you, I'm happy to try to respond when I can or try to make another video. But this is just something I like to do. It's something I've taught math for a little while. I'm doing this in my spare time, so just some things I think would be helpful. Some kind of basic concepts that you're going to see a lot of. Figured I would start off with just some pre-algebra, algebra vocabulary, and just some examples of each of the vocabulary terms as well. By no means am I covering every single vocab term because there's 1,000 of them, but just some ones that are good to know, basic. Whenever I teach math, I always tell students that words mean things. So it's good to know what they mean and good to use them correctly, especially in a practice as precise as math is. So jumping right in, I'm using a free recorder, so I get 15 minutes before I have to start a new video. So this will probably be part one of the algebra vocabulary, but just jumping right in there. A constant, a value that does not change. So pretty self-explanatory. Some examples of that. 9. 9 will always be 9. It will not be any other number. -3, 1/4. These are all values that are just going to stay as they are. So, 7.2. Another example, pi. Some of you might be thinking, well, that's a symbol. That's a variable, right? No, because a variable changes value. Pi is always going to be 3.1415, blah, 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 blah. So that does not change. Those are all examples of constants. A variable is going to be a symbol, generally going to be a letter that holds the place of an unknown value. So, for example, a lot of times you'll see A, you'll see N, you'll see X, you'll see Y, you'll see those a lot of times, any letter really. In geometry, you're going to run across theta, which usually stands for a missing angle measure. But pi is not a variable because it is always the same value. So that's all a variable is. It just holds the place of an unknown value. We can solve for those in certain situations. Integers, all the positive and negative whole numbers, and 0. That's all it is. No decimals, no fractions, nothing left over, no remainders. Okay, so integers, all the negative numbers, all the way -3, -2, -1, 0, 1, 2, 3, on and on and on. So only the whole numbers, positive, negative, including 0. So integers thrown around a lot. You gotta know what it means. The absolute value is the distance of a number or of a value from 0. So I always think of a number line. Absolute value is expressed as a value with bars around it. Vertical bars like that. So for example, if I ask for the absolute value of -3, that's just going to be 3 because -3 is 3 spaces from 0. If you think of a number line. Okay, here's -3. Pardon the handwriting, it's on a screen. So here's -3. We're counting the spaces to 0, 1, 2, 3. We only measure distance in distance in positives. So 3 spaces from 0. Whereas a positive value is obviously going to have, or positive absolute value is going to be positive as well. Absolute value of a positive number. So always going to be expressed as a positive. That's the key to absolute value. A factor is a number that's used to multiply, or you multiply by a certain number to create another number or another term. So there's a couple ways to look at this. If I'm multiplying a couple of numbers together, 3 times 4, I get 12. 3 and 4 are the factors that I used to get 12. So they're both factors of 12, in other words. There's also an expression, if I wrote the expression 7x, well, 7 and x are both factors because I'm multiplying the two of them together to create another value. Of course, x is unknown right now, so it could be anything. But 7 times x, those are both factors, 7 and x. Simple as that. You could also look at this as, if I had 7 times x plus 2, these are both factors, 7 and the quantity x plus 2, because I'm multiplying them together. They're going to create a new value, another term. I'm not going to get into multiplying them out right now. The coefficient is the number or the term in front of a variable, and it indicates the multiplication of that variable. In other words, how many of that variable there are. So as long as there's no sign separating them. So the example I just used, 7x. 7 is the coefficient because there are 7 x's, whatever that x value is. 7 of these. How many of that variable there are. That's it. Again, pretty simple, pretty concise once you really know the definition. A term can be a single number, a variable, or a product of one or more numbers and or variables. So just like we were saying a second ago, 9, that's a term. X, that's a term. Again, a product of one or more numbers or variables. So 3y is one term. Anything that's essentially not separated by a plus or a minus sign. So 3y is one term. If I said 4 minus x, those are two separate terms because they're separated by that minus sign. So those are two terms. And when it comes to terms, speaking of which, the sign in front of the value is always part of that term. So these would be the two terms. Make that little note right there. Okay. Like terms are terms that have the same variable and exponent. I'm going to actually keep term on the board here. Terms that have the same variable and exponent, basically these are the ones that could be added or subtracted together to be simplified into one term. So for example, 3x and 7x, they have the same variable and exponent. It's understood to be an exponent of 1 or a power of 1. 2y squared and negative 4y squared. They both have the y, they both have the squared. Okay? So those are like terms. And in that case, to be able to add or subtract them, you would just add or subtract the coefficients, keep the variable and exponent the same. We'll get into that when we get into operating with different kinds of terms. Another bonus example right here would be when you're dealing with roots. Let's say I have the cube root of 10 and then, 4 cube roots of 10. Same index, same root. They're both the cube root of 10. So those are like terms as well. They have different indices or different numbers under that root symbol. They would not be like terms. An operation. It's a process that changes two or more inputs to a single output. This is basically a fancy term for adding, subtracting, multiplying, dividing, exponents, roots, that kind of thing. So again, operations, the main operations, addition, subtraction, multiplication, and division. And then of course you're going to have exponents, and you're going to have roots. Those are the basic operations. You could argue that there's more. I didn't like that plus sign very much. You could argue that there's other ones, but those are the basic ones. To negate, this is a verb. It means to change from positive or negative, positive to negative, or vice versa. So we're just changing the sign. That's all it is. So if I move from a 4 to a negative 4, or I change it from a number from negative 5 to positive 5, I'm negating that term. Okay, this happens when you multiply or divide by a negative. We'll get into that more, but that's all that it means. Negate, change the sign. That's it. Positive to negative or negative to positive. An exponent. This is a term or something you'll see expressed as a superscript, a little number up off to the side, which indicates repeated multiplication of its base. So, for example, if I have x to the power of 3 or x to the third power, it's an exponent. All that's telling me to do is take the base x and multiply it by itself. Oops, got caught up in that. 3 times. So in this case, 3 is the exponent. It just repeats multiplication of its base, x. Okay, so another example. If I have negative 2 to the 4th power, negative 2 times negative 2 times negative 2 times negative 2 will be a little bit more specific with this later when we get to exponents and working with them a little more. Parentheses are a huge deal, not just in exponents, but especially in exponents. The root, sort of the opposite of an exponent. It's a value that when multiplied by itself a certain number of times, which is specified by the index, results in a given number. So you probably know several square roots, which is a root of 2. So for example, the square root of 9, a lot of you will say 3, but it's also negative 3. So plus or minus 3 would be the square root of 9. It's understood to have a little 2 right here. If it's not written, it's understood to be a square root. But that's just saying that if I multiply 3 or negative 3 by itself twice, I get 9. Same with negative 3. Another example, if I have the cube root of 8, that's what number times itself 3 times gives me 8. That's 2, not negative 2. We'll talk about why another time, but it's because the index is odd. And every time you multiply a number, a negative number, it changes the sign. It negates, so that won't work if I use negative 2. So you got to be a little more specific with the odd number roots. So 2 times 2 times 2 gives me 8. That's the only value that works that way, not negative 2. Moving on. Last couple, I think, for this first part. And a lot of these have to do with the result of a certain operation. Okay, the sum is the result of addition. So I used an example 3 plus 5 earlier. 8 is the sum. Simple as that. I added some numbers together, I got 8. 8 is the sum. And the difference is the result of subtraction. So 10 minus 7 is 3. 3 is the difference. That's it. They can be positive or negative as well. I'm just giving quick, easy examples. That's all it is. The result of addition, the result of subtraction. A product is the result of multiplication. So my example from earlier, 3 times 4, which is 12. 12 is the product. 3 times 4, 3 and 4 are the factors. And as always, this can be plain old ordinary numbers. This could be algebraic. So if I have, 3x times 4x, that's 12x squared. 12x squared is the product. Okay, doesn't matter. It's just the result of multiplication. The quotient is the result of division. 12 divided by 6 equals 2. 2 is the quotient. A lot of times in algebra, you're going to see division expressed as a fraction, though. So just be aware of that. So, you'll see 12 over 6. 2 is the quotient. Again, there could be algebraic terms in there. There could be variables. I'm not going to mess with that right this moment. Last one before we jump into part 2 is going to be a power, which is the result of exponents. You probably already know a lot of powers. But I'm doing 3 to the power of 2, or 3 squared, which is, again, 3 times 3. 9 is a power of 3 in this case. It's the result of multiplying 3 by itself over and over and over again. Okay? Some other powers of 3, if I kept multiplying by 3, would be 27. Another times 3 is going to be 81. These are all powers of 3. 9, 27, 81. Repeated multiplication. That's the result of an exponent. So I hope this helped a little bit. I'm going to continue on in part 2 here in just a moment on the next video. But feel free to reach out. Feel free to let me know if something didn't make sense. But I hope that helped.